Hey everybody, I am taking a break from helping my son with his schoolwork because that just ruins my day. It's kind of like butting heads. We don't do well together. So he's taking a break playing with action figures and I am taking a break to make another video, and today we're going to work on part 2 of section 9.2 with parabolas. So yesterday we delved more into parabolas that open up and down, and we learned some vocabulary. We learned focus, vertex, directrix. We learned that P means the distance between the focus and the vertex. It also represents the distance between the vertex and the directrix. We learned that the parabola opens around the focus. The directrix is on the other side of the parabola. It never touches the parabola, and it was a horizontal dotted line behind it. And so today we're going to work on parabolas that open to the left and to the right. So this is going to be pretty brand new for us, but a lot of the things are the same as what we learned yesterday. We're still going to have a focus, we're still going to have a vertex, and we're still going to have a directrix. However, things are a little bit different in that our parabolas are opening to the left and to the right. So one main difference that you'll notice is right here in the formula. So yesterday's formula, we had y equals 1 over 4p times x squared. But today's formula, we have x by itself. X equals 1 over 4p times y squared. And so that lets us know that this parabola is going to open to the left or to the right because it's solved for x. So the ones that have y by itself, or y to the first power by itself, those are parabolas that open up and down. But if you have an x to the first power and a y squared, those are the parabolas that open to the left and to the right. So instead of talking about parabolas opening up and down, we're talking about left and right. So when your value for p is positive, your parabola is going to open to the right. When your value for p is negative, your parabola is going to open to the left. Focus, directrix, vertex, they all still mean the same thing. They're just going in a different direction this time. So let's take a look at example number 1. We have x equals negative 1/8 y squared. So the first thing I'm going to do is take that negative 1/8 and I'm going to set it equal to 1 over 4p. Now remember when we did this yesterday, you have to decide where you want the negative to go. I'm going to put the negative with the 8, and then I'm going to cross multiply, so I have 4p equals negative 8, and if I divide both sides by 4, p is negative 2. So right away what I know is that this parabola is going to open to the left because my value for p is a negative number. My vertex for this is going to be 0, 0. And this goes back to, we don't have an h and a k, that means they're both zeros. So we're going to be right here at the origin. Our focus, remember the p represents your distance between your vertex and the focus. We already know we're going to go to the left. So from the vertex at the origin, I'm going to go to the left 2 spaces. That's going to give me my focus. I put a V for vertex. Now I'm going to go 2 spaces to the right, and that is where we are going to draw our directrix. Now here's what changes. That means that this is a vertical line and not a horizontal line. So when we write an equation for our directrix, we're no longer going to write y equals a number. We're going to write x equals a number. So in this case, x equals positive 2. And let me go back here and put my coordinates for the focus. It was at negative 2, 0. And now I'm going to make a table of values. I already know my vertex was 0, 0, so I'm going to put that in the denominator. I think I'm going to go by multiples of 2 just because my denominator of that fraction is an even number, and I think that might be easiest. Now here's the other thing that's also different, is this time we're not going to be plugging in numbers for x, we're going to plug in numbers for y. So I'm going to plug in multiples of 2. Again, you could just do the normal negative 1, negative 2, positive 1, positive 2. I don't know why I put a negative there, positive, and then we'll do a positive 4. All right, so let's see what we have. We're going to do -1/8 times -4 squared. Well, -4 squared turns into a +16, and when you multiply that times -1/8, you get a -2. Now the same thing should happen down here for the +4, but let's check it out. -1/8, we're going to plug in a 4. 4 squared also is 16. Yep, same y values. Or not y values, x values, right? We plugged in the y, we solved for the x. All right, this next one, we have -1/8, and we are plugging in a -2. -2 squared turns into +4, and -1/8 times 4 is -4/8, which reduces to -1/2. Same thing should happen here, but let's check it out. We have -1/8. We're plugging in a +2. 2 to the second power is also 4. So yeah, that's going to turn into -1/2. So let's plot what we have. We have -2, -4. Then we have -1/2, -2. We already have 0, 0 plotted. Then we have -1/2, +2. And lastly, we have -2, +4. So we get a parabola that opens to the left. It's opening around the focus exactly as it should. The directrix is behind it, and it is a vertical line because our parabola is opening to the left. So same concepts, just opening a different direction. So same thing is going to happen here with the h and the k. Now if you want, and I'm going to do this, I'm going to rewrite mine where I'm solving for x. I just like to get one variable by itself. All right, so the h and the k again are going to let us know what our vertex is. P still means the same thing. Again, if p is positive, we're going to open to the right. If p is negative, we're going to open to the left. So let's take a look at example number 2. I'm going to start by rewriting it. I'm going to add the 1 over to the other side. So I'm going to have x equals 1/12 onto y plus 2 squared plus 1. Oh, real quick, go back up here. I definitely have a typo. Let's fix it, shall we? H always goes with the x value, and the k always goes with the y value. So let's fix this real quick. That should be a k, and this should be the h. Now a couple things to notice, because this does change something real quick. In this case, the h is no longer the opposite of what you see. The h is going to be exactly what you see. Remember, Hayavas, that's a vertical change, and vertical changes are exactly what they see. This time, however, because the k is inside of the parentheses, that makes that a horizontal change. So the k is going to be the opposite of what we see. So you want to make sure you're paying attention to that. It does change that a little bit. So not that it's tricky, but it's just something you have to kind of be aware of. So let's take a look then together here, and we're going to work through this one slowly so we don't make any mistakes. First, let's identify the h and the k. This back here, that's going to be the h, and inside is where we're going to find the k. All right, now remember, because this is a vertical change, the h is exactly what we see. So the h is a +1. Remember the k, it's inside of the parentheses, so it is a horizontal change. It's going to be the opposite of what we see, so it's going to be a -2. And so right here I have the coordinates for the vertex. So we're going to be at 1, -2. I'm going to go ahead and plot that. You know what? I don't think I labeled my x and my y on the other side. Nope, sure didn't. Let's fix that right on up. Okay. So I have my vertex plotted already right here. All right, now I'm going to take a look at the fraction that we have, which is 1/12. And I'm going to set that equal to the 1/4p. And I'm going to cross multiply, so I get 4p equals 12. and dividing by 4 means that P is 3, and that tells us that we are going to be opening to the right. So we already have our vertex. Let's do the focus. So from the vertex, we're going to go 3 to the right. So I'm going to put an F for focus. So what are the coordinates of that? We are at 4, comma, -2. All right, the directrix, we're going to go the opposite direction. So we're going to go to the left 3 spaces. So 1, 2, 3. Again, you're going to do a dotted vertical line. This is also going to have x equals a number, and that number is -2 because that's the x coordinate that that vertical line is passing through. So there's our directrix. So now we need to make a table of values. I'm going to have more work on the x side, aren't I? So our vertex was 1, -2. And we can just plug in the normal numbers, a -3, -4, -1, and 0. Let's try that out and see what happens. So let's start with the -4. And I'm again going back to this equation right here. I'll keep my finger there. All right, so I have 1/12, parentheses, I'm going to plug in a -4. -4 plus 2 is -2. Then we're going to square -2. That's going to get us a +4. And then behind it, we're going to add 1. All right, well, 1/12 times 4 is 4/12, which reduces to a third, which we're adding to the 1. So we end up with 1 1/3, or if you want to write that as a mix, no, just kidding, that is a mixed number. If you want to write it as an improper fraction, you can change that to 4/3. That's up to you. Let's go ahead and plug in the -3. So I've got 1/12 in parentheses, -3 plus 2 is -1. And when you square -1, you get a +1. And when you multiply 1/12 times 1, you get 1/12. And then we're going to add it to 1, so we get 1 1/12. All right, let's plug in the -1. So -1 plus 2 is 1. 1 squared is 1. Looks like we're going to get exactly the same thing we did a moment ago, 1 1/12. Last one, 1/12. Plugging in a 0. 0 plus 2 is 2. 2 squared is 4. We're going to add the 1, and we're going to get the same thing, 1 1/3. So let's plot what we have. So we have 1 1/3, comma, -4. All right, then we have 1 1/12, comma, -3. Then we have 1 1/12, comma, -1. And then 1 1/12, no, just kidding, 1 1/3, comma, 0. So it's a parabola that's certainly going to be very wide, and I'm really doing a bad job, but there we go. Let me put arrows on that directrix. I'll put D for directrix. All right, so really the main differences are that this time H is going to be exactly what you see. K is going to be the opposite of what you see. That's a pretty big difference. The other main difference is that you're going to plug numbers in for Y, and this time you're going to be solving for X, which makes sense because in our equation we have X equals something. All right, so let's try example 3. All right, this one's different, kind of like yesterday's. It says that we want to rewrite it in standard form. So again, just like yesterday, we're going to have to do the process of completing the square. So one thing I'm going to go ahead and do is I'm going to go ahead and move that 8x and the 4 over to the other side. So I've got y squared minus 8y. I'm going to leave some space because we're going to do the completing the square process in a moment. I'm moving the 8x over, so it turns it into -8x. I'm also moving the 4 over. It turns that into -4. So I'm going to go ahead and put plus a blank on each side so that I remember that I'm completing the square. So remember this process. We're going to take half of b. So half of -8 is -4. Then we're going to square that. That turns that into positive 16. And I'm going to add that onto each side. So over here, this is now a perfect square trinomial. It factors into y minus 4 squared. Again, if you're struggling with that, you can do a sum and product chart, or you can go back and look at the notes for completing the square and remember how we learned to do that quickly. Over here, I'm going to combine like terms. So I have negative 8x plus 12. Okay, so remember on that side with the x's, I need to get the x to have a coefficient of 1. That means I need to take the negative 8 out. Now you might be wondering, well, that doesn't make any sense because 12 is not divisible by negative 8. And you're right, but we're going to have a fraction or a decimal, whichever you prefer. I'm going to stick with a fraction. The point is your x has to have a coefficient of a 1. So whatever number is with the x is what you need to take out. So I'm basically dividing by negative 8. So 12 divided by negative 8 would just turn into negative 3 over 2. Or if you like decimals, you can do negative 1.5. That's fine. All right, now remember, we have to get rid of that negative 8. And how do we do that? If you remember from yesterday, we're going to divide each side by negative 8. So here's what I now have. I have negative 1/8 times y minus 4 squared equals x minus 3/2. And then I like to go ahead and get the x by itself. So I'm going to add that 3/2 over. And now I have x by itself. All right, so that was a great review of completing the square. Now let's figure out the h and the k. Remember, because this is opening to the left and to the right, the h is exactly what you see. The k is the opposite of what you see. So the h is exactly what we see, so it is a positive 3/2. The k is the opposite of what we see, so it is going to be a positive 4. So there's our vertex. Now, well, let me go ahead and plot that. Let me go ahead and label my x and my y axis. So I'm going to go to 3/2, which is 1.5, comma 4. It's going to put me right there for the vertex. All right, now I want to find my focus, but guess what? I have to first solve for p. So I'm going to take that negative 1/8. I'm choosing to put the negative sign with the 8. I'm going to set it equal to 1 over 4p. If I cross multiply, I get 4p equals negative 8. That means p is negative 2. What that tells me right away is that this parabola is going to open to the left. So to find the coordinates of the focus, I'm simply going to go to the vertex, and I'm going to move over 2 spaces to the left. Notice it's right here in the middle of 1 and 2. So I'm going to move over 1, 2. It's going to put me right there. So what would that be as an ordered pair? That would be negative 1/2, comma 4. All right, then I'm going to go back to the vertex, and this time I'm going to move 2 spaces over to the right and come up with a directrix. So 1, 2, and draw my vertical line. D for directrix. What's the equation for that? It's going to be x equals 1, 2, 3.5. So 7 over 2. Or if you can write 3.5, that's fine. All right, so now we just need some ordered pairs, right? So let's put the vertex in the middle, which was 3/2, comma 4. Okay, so my fraction has an 8 in the denominator. I'm going to just stick with maybe going 2 aways from each one. So in other words, I'm going to go to 2 and 0. And on the other side, I'll do 6 and 8. Again, you can pick whatever numbers you want. All right, so let's start with the 0. So I'm going to have negative 1/8, parentheses, 0 minus 4, which is negative 4, squared is 16, and then plus 3/2. All right, well, negative 1/8 times 16 is 2. 2 plus 3/2. All right, 2 is the same thing as 4 over 2, so 4 over 2 and 3 over 2 add up to give us 7 over 2. All right, let's take a look at, hang on one second. Okay, all right, let's plug in a 2. So we have negative 1/8. Then we're going to do 0 minus 2, which is negative 2. Squared is 4. And then we're going to add 3/2 to it. All right, so negative 1/8 times 4 is negative 4/8, which reduces to negative 1/2. And then we're going to add 3/2 to it, which is 2 over 2, which is just a 1. Okay, next one, here we go. We're going to plug in a 6, so I'm going to have negative 1/8. All right, 6 minus 4 is 2. 2 squared is 4, plus 3/2. Same thing's going to happen. Negative 1/8 times 4 is negative 1/2. And we're going to add that to the 3/2. And that equals 2 over 2, which is 1. And then last one, negative 1/8. We're going to plug in an 8. 8 minus 4 is 4. 4 squared is 16. And then plus 3/2. You know what, y'all? I got to go back and fix the one up top. I knew something was weird about that because I totally left out the negative here. That was a negative 1/8 times 16. That's going to make that a negative 4 over 2, which is going to change this to negative 1/2, not the 7/2 that I had. So let's make sure I do this one right. So negative 1/8 times 16, again, is negative 2, and we're going to add 3/2 to it. Again, negative 2 is negative 4 over 2, and negative 4 over 2 plus 3 over 2 is negative 1 over 2. All right, at least I caught that mistake. So let's plot our points. So here we have negative 1/2, comma 0. So negative 1/2, comma 0. Then we have 1, comma 2. So 1, comma 2. Then we already did the vertex. Now we have 1, comma 6. So 1, 2, 3, 4, 5, 6. And then lastly, we have negative 1/2, comma 8. So negative 1/2, comma 8. And this one's looking pretty good. We're opening around the focus. The directrix is behind it. Everything looks good. All right, so here's what I'm going to encourage you to do, just like with yesterday's section. I want you to go ahead and try example 4, and then I'll have a second video that comes up that will have the work done for example 4, and then we'll do 5 and 6 together. So I will see you in just a couple minutes after you try example 4 on your own.